Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve your dream of getting 60 in upcoming KCET 2025 exam. Now, if you are following our channel from the beginning, then you should know that we have already completed almost all the second few chapters. Currently we are going through first few chapters. Once this is over, I will be doing the chapter wise revision, but before that it is important to learn all the chapters concepts. Okay, it will help you to get even in case the question paper is slightly difficult, then you can answer questions if you know all the concepts. Now every week we are doing KCET Premier League for every subject, physics, chemistry and maths. And if you have not yet joined our WhatsApp channel, the link is given in the description. Don't forget to join our WhatsApp channel. Now let's start with today's chapter. Today we are going to discuss about gravitation. It will be complete one short video. Here entire chapter of gravitation, important parts for KCET only will be discussed. Okay, so don't worry, during your first PU if you have struggled while learning this chapter, you don't need to worry too much about it, because from this chapter one, sometimes two question comes from this chapter. So we will restrict our discussions only for important concepts. Even some unimportant concepts are included in terms of KCET, but maybe in upcoming KCET 2025 exam they might add some different questions. So that's why I have included some questions which may not be prevalent in previous year questions of gravitation chapter. We will do the previous year questions of gravitation tomorrow, but before that I should also tell you that if you have struggled in this chapter, don't worry. I know many students struggled in this chapter. There will be easier concept for this chapter. There will be not much difficulty if you are preparing for KCET 2025. If you are preparing for JEE Mains, if you are preparing for JEE Advanced or NEET level exams, then you have to study much more than whatever we are going to discuss today. So this is only for KCET exam, right, as you know. So let's look into the list of contents, what all we are going to discuss today. We will start with Kepler's laws. There are 3 Kepler's laws that we will discuss. Then we will discuss universal law of gravitation. Then we will discuss acceleration due to gravity for different cases, and gravitational potential energy, the idea of gravitational potential energy. Then we will discuss escape speed, and lastly we will discuss about satellites. Okay, these are the main things that we are going to discuss in our lecture today. So let's start with Kepler's law. So what is Kepler's law? There are 3 laws. First law is laws of orbit or law of orbits. Okay, all planets move in elliptical orbits with the sun situated at one of the foci. Now I know that I hope that you have already completed ellipse in your mathematics class. Then you should know that an ellipse has 2 foci. This is an ellipse like a egg. Okay, the shape of the ellipse is like an egg. Okay, 2-dimensional egg, and it has 2 foci. One is here, F1, F2. Okay, and sun is not located at the center. Sun is located at one of the foci. Okay, so and the planets are rotating in an elliptical orbit. For Earth it is almost circle but not exact circle. Okay, it is near identical to a circle. Eccentricity of Earth's orbit is very such that it is very close to a circle. Okay, so if E is equal to 1, you know that it becomes a circle, and for Earth it is 0.9, about 0.9. So most practical cases we assume that Earth is almost rotating in a circle. Now circle is also a type of ellipse. So obviously as you know, so ellipse circle is also a special case of ellipse. So you can say that Earth is also orbiting around the sun in an elliptical path. Okay, and one of the foci where sun is located. That is very important. Okay, based on this concept. Next is law of areas. What is that? The line that joins any planet to the sun. The line that joins, suppose this is the planet. Okay, this is my planet. Any planet, it can be Earth, it can be Jupiter, it can be Mars, it can be any planet, right? Now the line that joins any planet to the sun sweeps equal areas in equal intervals of time. So suppose the planet was here for some time, and in some time t1, say in some time constant time t, it sweeps some area, say A. Okay, and the planet was in another, after some say after 7 months or 8 months, the planet is in a new position here. Suppose that again the planet is now at this position. Again, if you consider another time interval t, okay, and whatever area it will sweep, that will also be A. That is the meaning of the second law, right? So it sweeps out equal area in equal interval of time, right? Very simple. So only thing is that you might think, okay, if the planet is here, then what will happen? If the planet is here, planet was here, then obviously after some time t, it will cover such a distance that area remains constant. Okay, so after the same time, suppose the time is 1 month. Okay, in 1 month from here to here, the planet reaches from here to here. But when it is in this side, it will cover greater distance and it will have covered more distance, right? So basically, in other words, you can say that planet moves slowly when it is away from the star, and it moves faster when it is closer to the star. Okay, that is one way is beneficial for us. If you know the answer, you can answer comment that in the comment below. Now next part is law of periods, also very important, if you, especially if you are preparing for JEE mains exam. This law is very important. Okay, and also need students the square of the time period of the revolution. So if the planet say revolves for some time, say planet of revolution means a time taken to complete one complete cycle, right? For Earth it is almost 365 days. Okay, 365 days, 4 hours, we know that, right? So the square of the time period of the revolution of the planet is proportional to the cube of the semi-major axis of the ellipse. So semi-major axis, we know this is semi-major axis and it is denoted by symbol A. So t square is proportional to A cube. Okay, this is the law of periods. Okay, traced out by the planet. So this is basically semi-major axis. So whatever semi-major axis it will have, t square is equals to A cube. So here A is semi-major axis and t is time period. So don't confuse this law and this law. Some people often confuse with law of areas with the law of periods. They are not same, because sometimes people think, okay, this is time period, this is time, this is area. No, this is not area. This is semi-major axis, the length of the semi-major axis. Okay, so be careful. Now let's look into the next concept, universal law of gravitation. How many of you have never heard about the Apple and Newton story? I hope everyone know the legend. Okay, it was just a legend. Okay, there are a lot of historical facts that proves that it was actually not the time where Newton discovered gravity, but it helps him to explain the gravity. Okay, he already did the mathematical part, but he was looking for something which helps him to explain the thing, that why the apple is falling on the ground but it is not flying to the sky, or why the earth is not moving towards the apple. So these are the two questions that he has to answer, and he answered it using the famous equation F is equal to G m1 m2 by r square. Okay, there are a lot of stories, lot of theories behind this. I am not going to discuss everything from this formula. I will only teach you how to apply this formula. And here this term is called universal gravitational constant. It has a constant value. Okay, throughout the universe there is only one value, that is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. If you forget the unit, don't worry. Okay, for KCET you don't need to write the unit. Okay, you only need to remember 6.67 times 10 to the power of minus 11. If you remember, in your first PU annual exam, they asked you a question based on this constant of G, right? So what was the value of G, or what is the unit of G? But in KCET exam I have not seen that. That will be a very simple question, so they might not be able to not be asking you this question, right? So G is 6.67 times 10 to the power of minus 11 Newton meter square per kg square. But whatever question you might face in your KCET exam, there will be answers such that you don't need to use this value. Okay, 99.99% of cases you will not be actually using this value. Okay, you will be either replacing it with another constant that we will see, or it will be cancelling out each other. Okay, so we'll see one problem from this concept. What is this concept? Two bodies of masses 8 kg. So how many bodies? Two bodies. Okay, mass is 8 kg, are placed at the vertices of A and B of an equilateral triangle. Very important question. Okay, very important. You have to understand the question. So there is an equilateral triangle, right? So as soon as they told me that this is an equilateral triangle, I will draw an equilateral triangle. This is not so simple question. Okay, this is slightly trickier question. So that's why you have to be careful. Okay, so here suppose this is A, this is B, and this is C. Okay, and they have placed the two 8 kg masses are placed here, 8 kg A and B. Okay, 8 kg. Two masses are placed at these two locations, right? Now a third body of mass 2 kg is placed at the centroid G of the triangle. What is the meaning of centroid? Centroid means if you draw all the medians, okay, if you draw all the medians, there is a point where all the three medians coincide, right? If you remember, so this is called centroid, right? This is called the centroid. There is a different rules, different formulas are there, but fortunately for this problem we don't need to use too much geometry. We only need to know the concept of centroid. Okay, so I will only draw whatever is required. So centroid is this. Now what else? So here you have placed a mass of 2 kg, right? That was given in the question. Now if AG equals to BG equals to CG equals to 1 meter, so AG equals to 1 meter, BG equals to 1 meter, and CG is also 1 meter. Okay, where should a fourth body, okay, very important, where should a fourth body of mass 4 kg be placed? So we have a mass of 4 kg. You want to put it somewhere. Then what will happen? So that the resultant force on the 2 kg body is 0. So the resultant force on this 2 kg body will be 0. So let's understand the problem once more. We have a equilateral triangle. Equilateral triangle means all sides are same. A, B and C. There is a point G. Okay, and you have placed here 8 kg, here 8 kg and here 2 kg. All these distances are 1 meter, including this one. Okay, and they told you find a location for a third mass 4 kg where you will put it so that the resultant force on this mass is 0. Okay, you don't need these sides. Sides are not given, even it is not required. So why? Because we are trying to find the equilibrium of this mass, right? So equilibrium of this mass means only we need these two distances, right? So first let us find what is the force between A and G. So we know that masses always attract each other. Okay, unlike charges, masses always attract each other. They try to bring each other closer. Okay, charges, there may be opposite charges repel each other. Okay, and same charges opposite charges attract each other, my mistake, and same charges repel each other. But in case of masses, they always attract each other. So what is the direction of force on this mass due to this A? Will it be repelled or it will be attracted? It will be attracted. So attracted means the force will act in this direction, right? This will be the direction of force on this mass. Now what is the direction of force between G and B? Very important to understand, right? So this will be again getting attracted in this direction. Okay, so if these two forces are acting like this, and what is the angle between these two sides? So you know that for an equilateral triangle, all these angles are equals to what? For equilateral triangle, all the angles are 60 degrees, right? So all the angles are 60 degrees. Now they are bisector of the sides. Also for equilateral triangle, they are also bisector of the angles. If you remember, these are the basic properties of geometry. So this is also, if this angle is 60 degree, then this is 30 degrees. This will also be 30 degrees, right? If you remember. So let me clear this. I only need these two angles. So this will be 30 degrees. This will be 30 degrees. Okay, then what will be this angle? Now you can consider this to be a triangle, right? This is a triangle. This is a triangle means sum of all three angles will be 180 degrees. So 30 plus 30 is 60. So this must be 120 degrees. Right? This must be 120 degrees. Now what will be the... So now we have two vectors. One is like this, another one is like this, and we want to find the sum of these two vectors. So we can do the parallelogram method, we can do the triangle method. According to the parallelogram method, you will see that this will be nothing but along this direction. Okay, this will be along this direction. If I extend this, that the combined force will be along this direction. Okay, now this is easy to guess. If you look into the options, after I solve this problem, you will see that from the option there is only few options are there, so you can easily guess that. Okay, so the resultant of these two forces must be along the other meridian. That is also a property for triangle. Okay, for equilateral triangle. Now what is this resultant's value? What is this resultant value that we are interested in? Okay, if we can calculate this resultant value, then what we have to do to balance this force? To balance this force, we have to put a mass somewhere here. Okay, somewhere, I don't know the location exactly, along CG, okay, at some distance, so that this force is being balanced by an equal and opposite force acting in the opposite direction. So this force can be balanced using an opposite force which will be acting in this direction, right? So that they cancel each other. Here I will place our trump card 4 kg. Here I will place some point P. Okay, some point P I will place this 4 kg, so that the attractive force in this direction balances the sum of these two forces, right? First what we will do, first we will find these two forces. Okay, suppose this is F1, this is F2. Now what else you can say about F1 and F2? See, these two masses are same value, 8 and 2. This is also 8 and 2, right? So the magnitude of the forces F1 and F2 will be same, because the mass, pair of mass is same, only their direction is different, so their sum will be different. Their direction will be different only, but their magnitude should be same. So what is that magnitude? Say the magnitude I am saying F equals to F1 equals to F2, magnitude wise. Okay, that should be equals to G M1 M2 by R square. G M1 M2 R square, right? Both cases distance are same also, so it will be 16G. Okay, 1G, 2G, 3G, 4G, now it is 5G, and they are already in 16G state, right? Now what is the sum? What is the value of R? So here we have to use the formula for vector addition that we have learned. For two vectors A and B, if so f square a square plus b square plus 2ab cos theta, if you remember, right? Now what is theta here? Theta here is 120 degrees. That's why I was interested in this angle. So let's find r. f1 is 16g whole square, f2 is also 16g whole square. Or let me do one thing, let me not use the term 16g yet, let me use this term, let me use this will be easier. So f square plus f square plus 2f times f cos 120 degrees, right? Or we can write this as f square plus f square 2f square plus again 2f square cos 120 degrees. Now what we can do, we can take this f square as common, so it will come out of the square root and it will become f. So 2 is still there plus 2. What is the value of cos 120 degree? So if you remember, all sin, tan, cos. So this is 90. So 120 is somewhere here. So definitely cos theta will be negative. And how much negative? So for that you can either use sin 90 plus 30 theorem or cos 180 minus 60 theorem. Whatever you are comfortable with. If you are using cos 180 minus 60 theorem, then the value will be cos 60. Right? If you are using sin 90 plus 30 theorem, then it will be sin 30, which are both equals to half, and the sign will be based on this all sin tan cos, right? So you can simply do that, square root of 2, they will cancel, plus and minus minus, only 1 is left, so 2 minus 1 is 1, so here even resultant value is also f, so that will be equals to 16. Now I will use 16g. Okay, suppose I placed this 4 kg mass at a distance x. I have placed this 4 kg mass at a distance x. Now what is this magnitude of this force? The magnitude of this force should also be 16g, right? So that they balance each other. Now from laws of gravitation, okay, this mass is now 2, this is 4. So from laws of gravitation, this will be g times 2 into 4 times x square, because it is x, I am assuming, and that should be equals to 16g because of the equilibrium, so that the net force on 2 kg is 0. Now g cancels. Okay, sometimes I write 4 like g. So if you have any confusion, please check. Don't just check the calculations, check my voiceover as well, right? So it will be 8 by x square equals to 16, or x square equals to 8 by 16 equals to half, or x equals to 1 by root 2 meter. Okay, so x equals to 1 by root 2 meter. This is a long question in the standard of KCET. Okay, question is not super difficult but not super easy as well. Okay, at a point P on the line CG such that PG is equal to 1 by root 2 meter. Okay, definitely it will not be at C. If I want to achieve the equilibrium of the point, then it will not be C. If it was 8 kg, if this mass was 8 kg, then answer would have been at C. Okay, that is a shortcut trick. So all the masses are at the vertex, then at the centroid it will be automatically, all the forces will be balanced. But since it is a 4 kg, it will not be at C. In fact, it will not be even 0.5 meter as well. It will not be 0.5 meter. It depends on the square root, right? So that's why you have to solve the question. As I said, in terms of KCET standard, this is not super easy, but This question is however very important, and maybe if you are preparing for any other competitive exam, similar questions might come. That's why I have solved it, and if the same question comes in your KCET exam, then you know the answer already, okay, and if they change the value, then you have to solve it, right? Now let's look into the acceleration due to gravity. Now we know that if we have an object, okay, and if we drop it from some height, then it will generally accelerate downward with a value, and we call that value as g, okay, gravitational acceleration or acceleration due to gravity. And for most purposes around Earth, we consider this value to be 9.8 meter per second square, and for our problem solving questions we assume this to be 10 meter per second square, the round figure value. Okay, these are the very two common things, right? And but sometimes in case of gravity related question, gravitation related question, this is not enough. You need to know the formula for g. What is the formula for g? So on the surface of the earth, that is when we are standing close to the earth, it is not exactly on the surface of the earth. If it is almost close to the earth, then also you can use this same formula, that is g equals to gme by re square. What is me? Me is obviously mass of the earth, and re is radius. It has a value 6400 kilometers, right? Mass is also has a value. If you put all these values, then you will get this relationship, okay? But sometimes it's better to use this formula rather than 9.8, okay? We will see that as well. But is it a constant throughout? So on the surface of the earth, okay, there are certain things that you should know, that at poles it is maximum, okay, and at equator it is minimum, but on an average on the surface of the earth we generally consider it to be a constant. Okay, on the surface of the earth we generally consider it to be a constant, but because the radius of the earth here we take as an average radius of the earth. We know the earth is not a flat circle, right, flat sphere. But as you go down inside the earth, so suppose you are a mining worker, you are working in a mine, or if you go up in the space higher up, okay, suppose you are traveling in a plane, or if you are working like Sunita Williams in the International Space Station, then there the gravitational acceleration is not the same. Okay, now I know some of you might be thinking that, sir, I know that in space station their gravity is zero. That is a different reason. We will discuss that in a while. But there is a gravitational acceleration there as well. Okay, and that gravitational acceleration is not as same as the earth. Okay, it changes, variable it changes. In fact, in moon also you will feel the gravitational acceleration due to earth, but that is much lesser than the compared to whatever we are feeling on the surface of the earth, right? So now how it changes as you are going down, as you are going below, and you are working in a mine, or you are visiting a mine, or you are a mine engineer. In future some of you will become a mining engineer, and then you have to go inside the earth. Then how the gravitational acceleration will change? So below the surface of the earth at a depth d, okay, d is depth here, at some depth, so 5 kilometer depth or 10 kilometer depth, or like the Mariana Trench, that is the lowest point on the surface of the earth. You know that it is under Indian Ocean, so that is 11 kilometer deep. So if you go up to that below, then possibly you will feel the gravity is much lesser. What is the value of gravity there? Gravitational acceleration at that point of time is basically g. Here g is the surface on the earth, right? G is the normal value that we know, 10. Okay, 1 minus d by re. Okay, as you are going inside and inside, the gravitational acceleration slowly decreases, and at the center of the earth, when d equals to re, when you have achieved of dream that you have reached the center of the earth, at that point obviously gravitational acceleration will be 0. Gravitational acceleration at the center of the earth is 0. So if they ask you at where the gravitational acceleration will be 0, gravitational acceleration will be 0 as you reach the center of the earth. Okay, and as you can see, the gravitational acceleration has a linear relationship here, okay, with the distance, right? So if you plot the graph, it increases linearly and it becomes maximum on the surface of the earth. We will see the second half of the graph as well. Okay, so as you are increasing d, suppose this is d, okay, and this is g, value of g, the g, gravitational acceleration, increases linearly as you are moving from the center of the earth. Okay, so there is a novel called Journey to the Center of the Earth by Jules Verne. If you have read that book, please tell me. That was a science fiction, very nice science fiction. Okay, and they have said that how they are going to travel towards the center of the earth. Okay, and there were some movies also, science fiction movies. There is a movie called The Core. Okay, I know maybe some of you have never heard of this movie. Okay, there they showed how some group of people are traveling towards the center of the earth. Okay, so that is also a good movie. Now let's see what will happen if we move up. Like Sunita Williams is currently staying in International Space Station. What will happen to her gravity? So as you are moving up, okay, the gravitational acceleration decreases. How it decreases? It decreases using this formula, gh at some height h, g equals to g by 1 plus h re whole square. So here also, as you see, the gravitational acceleration decreasing. So if you complete the graph, there was a question how the gravitational acceleration decreases. So this is the graph. Okay, so it linear as you are reaching the surface. At the surface it is maximum, and as you are going down, again now it is inverse square law. As you can see, it is decreasing like this, and at infinity the gravitational acceleration is obviously will be 0. Okay, so this is the variation of this is re, this is say normal distance r, this is g, and this is the maximum value of gravitational acceleration, that is 9.8. So this is on the surface, that is we are feeling this. Okay, rest as you are going down, some fishes inside the seawater. Okay, and here the fishes are here, fish, and here is the space station. Okay, International Space Station, Sunita Williams. Okay, they are working here, so they will feel less gravity. Okay, their gravitational acceleration there is much less than what we feel on the surface of the earth. Not super less, but still it is very less. Now if the distance is not super high, okay, for example, if you move to the top of Burj Khalifa, which is almost 2 kilometers long or 1 kilometer long, I think. Okay, so if you are on the top of Burj Khalifa, 1 point something kilometer long, so in that case what will happen to the gravity? Will you feel the same gravity if you are standing on the surface of the earth, or the gravitation will decrease, gravitational acceleration will decrease? So definitely gravitational acceleration will decrease because you are at a higher altitude. But for higher altitude we do not need to calculate this exact value because re is very high, right? We know that re is 6400 kilometers. So for distances where h is very less compared to the radius of the earth, we can approximate this formula. There is a binomial approximation, this is called binomial approximation. This formula can be approximated using this formula. Okay, and most of the cases you have to use this formula. Okay, for NEET and for KCET, this formula is more important compared to this formula. For JEE Mains and JEE Advanced, you have to learn both formulas. Okay, in some cases they will ask you problems based on this formula, some cases they will ask you problems based on this formula. Okay, but for NEET and KCET students, this is the only formula that you have to remember. Okay, based on this formula a lot of questions come based on this only concept, acceleration due to gravity. If you see gravity on the surface of the earth, gravity in some depth, okay, gravity at some height, sometimes they will say gravity at some x distance, gravity at some height distance, they will ask you to compare it. Okay, so this formula is going to be very, very important. Okay, now for h is very less than re, okay, but you also have to remember this formula for some cases as well. So cases students also need to remember this formula. This is easy to remember. Okay, and this is an approximated value, 2h by re. Okay, now let's see one problem. the value of acceleration due to gravity at a height of 10 km from the surface of the earth is x. Now you can consider this height 10 km is very small compared to the gravitational acceleration on the surface of the earth, right? So you can approximate this, the formula that I told you, g equals to gh equals to g times 1 minus 2h by re. You can approximate this formula for this question because 10 km is very small, right? Suppose you are standing on the top of Everest, which is almost 8 km long, suppose 9 km, round figure 9 km long. Okay, so like that. So gravity at the height of 10 km from the surface of the earth is x. At what depth inside the earth is the same value of the acceleration due to gravity has the same value x. So basically what is the question? At some height x, okay, you have some gravity at some height 10 km. At some height 10 km, you have a gravitational acceleration x. Okay, as you are going up, we know that gravitational acceleration decreases. Now as you go down, after going down some depth, again it will be the same value x. So they asked you at what distance inside the earth or at what depth inside the earth it will be the same value x. Okay, I hope it is clear. So basically they told you that g 1 minus 2h by re equals to x. This value is x, and we know that gd is given by g 1 plus d by re. Okay, so basically if you remember these two formulas, they are easy to remember, they are almost same, and that is also equals to x. So you have to find at what distance d this will be x, and here we know that h is equals to 10 km, that is given. So what we will do, x is unknown value, so we will eliminate this by comparing these two values. So basically what they told you, 1 minus 2 times 10 divided by re equals to g times 1 plus d by re, right? So g cancels. Okay, 1 minus 2 times 20 by re equals to sorry, here it is also negative. One minus d by re, right? So 1 cancels, minus cancels, so what is left? 20 by re is equal to d by re. Re cancels, so we get d equals to 20 km, right? So d should be equals to 20 km. Simple. So if you solve such questions, your knowledge about similar questions will be clear. So you can answer, if the same question comes again, you know that okay, if the distance is 10 kilometers, the answer will be 20 kilometers. If the distance is 15 kilometers, it will be 30 kilometers. Similarly, in the reverse way, if they ask you the question, inside the earth some value is x, at what height it will be same value x. Then in that case, you know that if the inside value is 40 kilometers, at height 20 kilometers it will be the same value. So if you are going whatever height, it will get doubled when you are inside the earth, right? So that is the main thing you need to remember. Now let's look into gravitational potential energy. This is also very less asked questions for KCET, but there is one question that came from this concept. So I am going to discuss what is gravitational potential energy. It is very similar to electrical potential energy. So when you have two objects close to each other, they will attract each other, right? So they are attracting each other. So whenever they are attracting each other, if you want to tear them apart, take them away, that means you have to apply external energy into the system. That energy is called gravitational potential energy. So what is the value of the gravitational potential energy? Gravitational potential energy is given by V equals to G m1 m2 by R. Okay, by default it is negative because when we want to separate them, we have to do external work, but the system has negative potential energy. That means you have to do work to separate them or keep them at their position. That is the meaning of this negative sign. Okay, external work needs to be done. What else? As R tends to infinity, so as you are taking the distance, if the objects are kept at infinite distance, obviously the potential energy becomes zero, as you can see, right? Also, work done to move a mass, suppose there are two masses m1 and m2, okay, and if you want to move them apart, suppose initial potential energy was V1, after you take them at some distance, so initial distance was suppose R1, now you took them to a distance say R2, and now the potential energy of the system is V2. Then how much work you have done? The work you have done is basically work done is equal to delta V. Delta V means, now in this case delta V means initial minus final, because it is negative it will be initial minus final. Okay, so work done is delta V. Got it? Now a mass of m on the surface of the earth is shifted to a target equal to the radius of the earth. So what is the question? Very interesting question. This is earth. Okay, a mass m was kept on the surface of the earth. Okay, and it is shifted to a target. Now this mass m was shifted to a target. Initially it was on the surface of the earth. It is shifted to a target equal to the radius of the earth. So equal to the radius of the earth. So if the radius of the earth, suppose it is given that if r is the radius of the earth, okay, r is radius, so you take this object to a height, this is also r. Okay, so this is the question. If r is the radius and m is the mass of the earth, then the work done in the process is. Then they have asked you to find the work done in the process when you move this mass from surface of the earth. It was initially on the surface of the earth, now it is at a distance r from the surface of the earth. What is the work done? So first what you have to do, you have to calculate the initial potential energy, and to solve such questions you can ignore the negative sign. Okay, as simple as that, you can ignore the negative sign. First, what was the potential energy of the system? G m m by r square. Sorry, G m by r, potential energy, right? So it will be only single r. So this was the initial potential energy of the system when the mass is kept on the surface of the earth. Now as you have taken the object to another distance r, now what is the distance of this between the center of the earth and this mass? Basically here the distance is basically center of the earth to the mass. Initial distance was r. What is the final distance? This is r, this is also r, so the total distance should be 2r, isn't it? So what is the final potential energy? Final potential energy will be Gm m by 2r. As simple as that. So this is the final potential energy. So what is the work done now? So work done will be given by Gmm by r minus Gmm by 2r. Okay, so Gmm by r is common. And you can write this as 1 minus half. Okay, now if you see the option, in the option there they have not mentioned the value of G, value of M, only R is there. Why so? And they have introduced this gravitational acceleration G. So what we have to do, we have to reorganize this. How we can reorganize this? To work done is given by, now 1 minus half is half. So so let me write half first. Okay, now what we will do, we will write Gm by r square times Rm. What we have done, we have multiplied with r in the denominator as well as in the numerator, right? Now what is this Gm by r square? Gm by r square is nothing but gravitational acceleration. So it will be half G r m. Let me reorganize this, m g r by 2, right? So the correct answer is mgr by 2. Okay, if you know this formula, this is a simple problem. If you don't know this formula, this is going to be a difficult problem. Okay, now next, escape speed. Escape speed, we know that we are standing on the surface of the earth. The minimum speed that is required to escape the gravitational acceleration of the earth. So what is that equation? Equation is V is equal to square root of 2g re. Now there is no question came from the concept of escape speed, but the formula is important. Might be upcoming year, this 2025 year, they might ask you some question based on the escape speed. So it is better to know about the formula for escape speed. V is equal to twice square root of g re. Okay, that is the escape speed when it is on the surface of the earth. Okay, in JEE Advanced, JEE Mains, they might ask you what is the escape speed as it is going out. It is rotating, suppose at a distance r. So that case G will change, escape speed will also change, right? Now satellites. What is a satellite? We know that satellite is nothing but whatever we launch into the orbit and they rotate around the earth in a circular orbit, right? There are different types of orbits. Okay, there are some orbits which is very close to the earth. Okay, for example, the GPS satellite, you might have used GPS in your mobile to find location. They are rotating very close to the earth. Okay, similarly the International Space Station, that is also rotating very close to the earth. They are not very far. Even if you observe at correct time, you might spot it in the sky if you are watching it properly. Okay, there is a app called ISS tracker. You can even track where it is right now. Okay, now so that is the satellite. That is a type of satellite, whatever is rotating around the earth. Sometimes we send satellites to exoplanets as well. For example, we have sent satellites to Mars. We have sent satellite to moon as well, right? So those are all satellites. Chandrayaan 1, Chandrayaan 2, they are all satellites. Okay, even a moon itself is a satellite of earth, but that is a natural satellite. Okay, here we are mainly talking about artificial satellites. So what is the formula for velocity? When the satellite is in the orbit, okay, it is rotating with the velocity, fixed velocity, so that it can maintain that orbit. If the velocity is greater than that, then it will slowly move away from the earth, and if the velocity is less than that, then it will slowly fall back to the earth. Okay, that's what happens when a satellite runs out its course. Slowly it falls back on the earth and it is getting destroyed, right? So that is the minimum velocity, that is the velocity required for a satellite to stay in the orbit, particular orbit. Every satellite has a fixed satellite velocity, and if you see, it does not depend on the mass of the satellite. Okay, it is independent of the mass of the satellite, and it is actually square root of GRE. Okay, RE is the radius of the earth. Now on the time period of the satellite is given by T0 equals to 2 pi GRE by G. Now these are all calculated where we are considering the satellite is very close to the earth. Okay, so whatever other value that we have, that is almost getting cancelled. So this is very important. If you remember, on the surface of the earth, if you put the values, you will get this value to be equals to 85 minutes. Okay, so if you put a value of RE 6400 kilometers, if you put the value of G, okay, then you will get this satellite. If suppose what is the meaning of this? So suppose we have a satellite which is rotating very close to the surface of the earth, say 1 kilometer distance. Okay, then it requires 85 minutes to complete one full rotation around earth. This is the time period. Okay, This is the time period required for the satellite when it is rotating around the earth at a very close range. Okay, so almost all of our GPS satellite has this time period. Okay, now that means it completes one rotation around earth in 85 minutes. Very important. Look into this question. This came in little older question, but it is still in from your KCET question paper. What is the period of revolution of Earth satellite? Ignore the height of the satellite above the surface of the Earth. So they have asked you to ignore the height. So basically it is rotating very close to the surface of the Earth. Then what is the time period? So time period, take G is 10 meter per second, take R is 6400 kilometer, take pi is equal to 3.14, and we know that the value is already we have calculated. It is 85 minutes. If you don't know, then you have to use that formula to calculate it. Okay, 2 pi square root of RE by G. Okay, you can calculate that, or you can use the known fact. And in this case, we will get this is in seconds. Okay, so what you have to do, first you have to find it in seconds, then divide it by 60 to calculate the minutes, right? So that is the one thing. So you might think, sir, the value is not matching 6400 and 6400 kilometer is there. You have to convert it into meters first. Okay, then only you can apply that formula. Or you can do one more thing. You can remember just this. Okay, and you can simply answer, okay, it is 85 minutes, so it will be 85 minutes, right? Now we have reached the end of today's lecture, and as usual I am here to talk about my special bookmark. You have to do there is a playlist available on our channel. Okay, especially all the lectures that I am doing, all are organized way. So if you want to check any of the videos that you have missed, or if you want to study any of the chapters that I have already completed, you can visit our playlist, you can check that video, you can learn from there and bookmark this playlist. Okay, and obviously, as I said at the beginning of the video, you have to join our WhatsApp channel. There we are doing KCET Premier League. Every Sunday we are conducting question paper. You are giving you a question paper. From there you have to answer the questions, and at night I will be bringing you the solution to that. But how can you download the question paper? For that you have to join our WhatsApp channel. The link is given in the description below. Also, if you are watching this video for the first time, don't forget to subscribe to our channel and share this video with your friends. I will be back with gravitation previous year questions tomorrow. Till then, as usual, tata, bye bye.